All right, first formative of the year. How did it go? Did you need to go back on your notes? If you didn't need to go back on your notes, you probably were really prepared. You did all of the lessons in class. You understood everything. Good job. You were on an awesome track to do well on your summative. If you found yourself really confused, needing to go back to your notes, or cheat off of one of your friends, that probably means that you weren't doing the work properly. Maybe you were just copying my answer key and turning things in. You didn't actually learn anything. So if you didn't do very well on this formative, that's okay. Maybe put a little bit more effort into doing the classwork. I know sometimes it's tedious, but it's the best way to actually learn and understand and master this material.
All right, so diving into question 1. This question was actually, I thought, a little bit tricky because of the way that the problem is worded. And if you're a big English nerd, for lack of a better term, if you are really trying to pick apart the way that the words are being used, there's 2 ways that you could really interpret this. And as long as your explanation matched what you were saying and it followed along with what the problem was saying, I did give you the points just because the wording is kind of a little tricky. So I'll go over both ways to answer this question. So Hector is purchasing Matchbox cars for his son's birthday. He knows there's a relationship, so relationship, nice big keyword there, between the number of Matchbox cars he purchases and the total amount of money he spends. Identify the independent quantity and the dependent quantity in the problem situation. Okay, so first way, the way that I interpreted this was that the number of Matchbox cars he can buy was my independent, and the total amount of money he spends, and I feel like I sound like a robot when I'm writing and talking at the same time. I'm sorry about that. So the total amount of money he spends is my dependent quantity, because the total amount of money he spends depends on the number of Matchbox cars that he buys. Or so I guess my wording is wrong. The total amount of money he spends depends on the number of Matchbox cars he buys. So that's one way to interpret it, because I took this actual wording right here and I put it as my dependent quantity. So I just copy and pasted their wording, and then for my explanation, I said the total amount of money Hector spends, which was this dependent, depends on the number of Matchbox cars he buys, which was my independent quantity. Because remember, the dependent depends on the independent. Remember, that was our little saying of this section here. So that was the first way. I'll change colors and do the second way you could interpret it. And it's with these 2 flipped around. So it'll be your the total amount of money he has is your independent, because maybe you're thinking he walked into the store with a set amount of money. He went into the store with $15. And so from that, the dependent is the number of cars he can buy. So the number of cars he can buy is dependent, depends on the total amount of money he has, independent. Okay, so I'm not going to write out the explanation because it's kind of long. I think I said it enough, and I just plugged in independent. I just plugged in my dependent, plugged in my independent into my little saying. So those were the two different ways that you could interpret this problem. Either one, so long as your explanation was correct, would get you the full points. If you wanted to take it a step further and really go into detail with your explanation, I may or may not have awarded 5 points on this question for your excellent answers. All right. And then number 2, Angela's grandfather gave her $10 to buy raffle tickets that cost $1 each for her cheerleading fundraiser. Identify the independent and dependent quantity in the problem. Label the X and Y axis with the appropriate quantity. So for this one, I only did accept one answer for this because there was a graph given and you really had to follow what the graph was saying. So for this one, independent quantity is the number of tickets she buys, and the dependent was the amount of money she has left. So we know that she's starting with the $10, right? And she's buying tickets for $1 each. So this down here, the independent is the number of tickets she buys. Number of tickets she buys, that's my X. I plug that into my formula, and what do I get out? I get out the money she has left. So if she started at $10, so she buys 0 tickets. 0 tickets right here. Actually, I'm going to highlight it, not circle it. She buys 0 tickets. That means she has $10 left. If she buys 1 ticket, that means she has $9 left. If she buys 6 tickets, she's got $4 left. If she buys 10 tickets, she has $0 left. All right. So maybe that one took a little bit of thinking because they were giving you a lot of information in the problem, but it's pretty important to use that graph to help you figure out your independent, dependent quantities. And after I identified my independent and dependent quantities, I labeled my graph, and then I looked at the graph to make sure that it matched up with what I was saying. And then this last one is just a skills review, spiraled question, something that you've already learned before in our Math 1 skills review packet. Solving for X. So maybe you still like to draw that line down the middle. We're going to follow our order of operations. So we're going to distribute this -2 to the parentheses to get rid of my parentheses. And I have 7 minus 2x plus -2 times -5 is positive, so plus 10 equals 13. Then I will combine my like terms. So I've got -2x plus 17. So 7 plus 10 is 17 equals 13. Move all my numbers. So everything without a variable attached, I'm going to move that to the right-hand side. So it's a positive 17 on this side. So I need to subtract, do the opposite to both sides. I'm left with -2x equals -4. I got -2x, so -2 times x. Need to do the opposite, which is division. So divide both sides by -2, and I'm left with x equals 2. And if you're a little rusty still on your solving, remember I said you could always take this x, plug it back in to see if it makes a true statement. So we have 7 minus 2 times 2 minus 5 equals 13. Follow our order of operations to solve. 7 minus 2 times, I'm doing my parentheses first. 2 minus 5 is negative 3 equals 13. And then I have 7. Negative 2 times negative 3 is a plus 6 equals 13. 7 plus 6 is 13 equals 13. That is a true statement because 13 equals itself equals 13. True, so that means that my solution was in fact x equals 2. All right, hopefully that cleared up any confusions, answered some questions that you might have had. If there's anything further, as always, send me an email. Have a good day.